Everybody get to where we left off. This is a box and whisker plot. There's actually two of them. This is a box and whisker plot for the test scores for first period and a second period class. And they want us, I guess, to compare, decide if the following statements are true or false. And if it's false, rewrite it so that it's true. Fun. Okay. So the median score for first period is lower than the median for second period. On a box and whisker plot, where do you find the median? ¿Dónde se findo the median? Where do you find the median on a box and whisker plot? Yeah, find the middle of the box. It's in the middle of the box. So the median for the top one, it looks around 85-ish. Median for the bottom one is at 80. So it says the median score for first period is lower than second. That would obviously be false because first period it's somewhere in the mid 80s. And then how would I rewrite it to make it true? I'm not going to write the full statement again, but I would just scratch off lower and change higher. Write the whole thing if you want. So excited, I'm getting a new microphone, a new headset. So that's exciting. If I can charge it, I'm supposed to get it today. If I can charge it today, then I'll have it for tomorrow, even though we're not going to use it tomorrow because we'll be testing. But still, I'll have it. Things are looking up. All right, the Q3, which is the upper quartile, score for second period is approximately 85. So Q3 is the right edge of the box in the box and whisker. So for second period, that's Q3 right there, and that does appear to be approximately 85. We don't know for sure because of the precision of this number line that they have on the bottom, but it does appear to be pretty much around 85. The highest test grade, what's another name for the highest of a group of data? The max, sure. And they don't have points here. I wish I had points, but the highest test grade was in first period. Well, for the highest test grade, unless there's an outlier, but there's no evidence of any outliers here. So we go to the right edge of the whisker, and it does appear that the highest grade was in first period. It looks to be maybe just somewhere just shy of 95, maybe even 95, but that appears to be true. And then the lowest test grade was in second period. Well, that would be on the left side of the whisker. That appears to be false. Why? Why would that be false? Yeah, it looks about the same. It looks like they have both the same minimum. So the lowest test grade, if I were to rewrite this, was maybe change this from second period to in both first and second period. Any questions there? I mean, I don't want to get your hopes up, but at the same time, maybe this will ease some stress. Like, I looked at the quiz already, and it should be a pretty easy one, man. Like, as long as you guys are paying attention, there's no reason why we shouldn't have 16 different hundreds on it. It should be a pretty simple quiz tomorrow, but that doesn't mean anything. There's been plenty before that I thought have been really easy, and the people bombed it. So, at least we'll be dressed nice for it. Okay, let's go second to last page. Box and whisker plots. Let's create a box and whisker plot for the following data sets. All right, so we're starting to get repetitive now. Like, there's really nothing new before we go into the quiz tomorrow. We did some box and whisker plots yesterday. We can just practice it more. Box and whisker plots have to do with median. So we need to make sure that these elements of data are in order, in numerical order. The first one, A, already is. So, how many elements of data are there on the in 1A? In 1A, how many elements of data are there? There are 7. So in the middle we have an 8. 8 is the median. I can go up over here and plot point on 8. That's going to be my median. I know that that's going to take a vertical line, so I could even do that. Okay, now let's find our quartiles. On when you have an odd amount, we were talking about this yesterday. When you have an odd amount, Mikai, and you're gonna look for your quartiles, you ignore the median. So, like in total, if I had 7, I would have to ignore it. Therefore, I have the same amount on each side. There's 3 elements on each side. That's also an odd number, so there's going to be clearly one in the middle. So Q1 is going to be 4, and Q3 is going to be 12. So we'll plot those. 4, 12. Boxy box. What is my min? What's my min? Yours. It is 3. What's my max? 15. But we don't know yet if we want to take the whiskers there. We don't know if we want the whiskers to extend to them because we have to figure out whether or not those are outliers or not. If it's an outlier, it doesn't get the whisker. You take the whisker to the one before. So the way we do that is first you got to calculate interquartile range. What's my interquartile range here? Interquartile range is 8. How'd you get that 8? Good enough. Q3 minus Q1, which is 12 minus 4, which is 8. But then you got to get that 8 and multiply it times 1.5. 8 times 1.5 is going to be 12. So if anything falls either 12 less than Q1 or 12 greater than Q3, then it would be an outlier. But since Q1 is 4, 4 minus 12 is negative 8, and Q3 is 12, 12 plus 12 is 24. Does anything fall outside of negative 8 and 24? No, so you can give them the whiskers. Huh? 4 plus 12? No, the high end is 12. Q3 is 12. 12 plus 12. On the low end, you subtract 4 minus 12. So we want to see if anything falls outside, like less than negative 8 or greater than 24. Nothing does, so you can give it the whisker. Yay, box and whisker plot. You guys want to try to do B by yourself, or do you want me to do it with you? Yeah, this one's good to do by yourself because it also has 7, so it's like the same zone. Let's just do this. You do it quietly, I do it quietly, and then we compare. And if we have something different, then we can fight about it. I finished. So if you finish, you compare to mine and see if it's different, and then we can see. Now, overall, whether or not, even if you have the same as what I have, what, from my recollection, what is different between this one and what we've seen the past 2 days? I don't recall having one just like this. Yeah, there's no left whisker here. I don't remember having seen that before. There's no left whisker because the minimum is the same as Q1. Yeah. Where did the 1.5? The 1.5 is always there. That's when you're gonna calculate outliers, you get the interquartile range to 7 and multiply it times 1.5. That's the formula, if you will, for looking for outliers. Once you multiply the interquartile range times 1.5, you would subtract it from quartile 1 and add it to quartile 3. If there's any data remaining that falls outside of that, it's considered to be an outlier. Is anybody still working on 1B before I move on to 1C? Kiara, you understand 1B? Okay, I'm gonna do 1C now. Just real quick before we do this separately again, what appears to be different about 1C than the first two? What's the big major difference on the front end? I haven't even graphed. I don't know what the graph is gonna look like. Who knows? Maybe there's outliers. So I'm not even getting just on the front end at the very, very beginning when I start. What appears to be different from 1C than the first two? Yeah, there's an even amount. So when it comes to calculate median, there's an even amount. So I have to know how to do that. Still got to put them in order. Okay, so I'm finished. I don't know if you're finished, but if we're both finished with 1C, compare it. Did it end up having any outliers? Did 1C have any outliers? Somebody not named Anna Marquise would be nice if they could answer Nakai. Huh? Yeah, there's no outliers there. That's what I did the whole 1.5 times 1.5 PR 7.5. There is nothing that is 7.5 less than Q1 or 7.5 more than Q3. Nothing falls outside of that, so you can take the whisker all the way to the minimum and the maximum. Also, because there was an even amount what we started with, the median is at 8.5 because I had to average 8 and 9. 8 plus 9 divided by 2 is 8.5, so that's where the median went. But then the chi, when it came time to calculate those quartiles, when you have an even amount, you leave everything in. So to calculate the quartiles is what's the median of the first 5, what's the median of the second 5. You leave everything in. So read the median of the first 5. It's the odd number, is the one in the middle. The median of the second 5 is the 12 Q3. Any questions there? And land, is that confusion? You're staring at something. Oh, I did it backwards, didn't I? Okay, well, it's not gonna affect any outliers, but yeah, thank you, I did that wrong. I'll fix that, thank you. So yeah, it should have been 12 minus 5, which is 7. And then 7 times 1.5, just like before, is going to be 10.5. So, but regardless of anything that's bigger, so there's no, the whole purpose of this is just to see if there's any outliers. There still are no outliers. Any question anywhere on any of the box and whisker plots from question 1? All right, let's move on to question 2 then. Determine the suggested statistical measures and answer the questions based on the graph. All right, what's the minimum here? 0. What's the what's Q3? It is 6. That's the right edge of the box. What is the interquartile range? Well, it's not going to be 6 because it's 6 minus 1, which is 5. And then the range is max minus min. So the max here is 8. 8 minus 0 is 8. Which quartile has the most variation? Okay, well let's do this. So we've referred to quartiles as individual locations, but really what they're referring to in this question, what a quartile does is it breaks up a set into quarters, into fourths. So the first quartile is everything that's before from the first quartile is everything that goes from the minimum to Q1. This is the first one. Everything that goes from Q1 to Q2 is the second quartile. Everything that goes from Q2 to Q3, that's the third quarter. This is the third quarter. And then the last quarter is from Q3, really all the way to the max. Even if the max was an outlier, it would still be considered part of the fourth quartile. So which one has the most variation? Variation means that it's spread out further. Which one's the widest? Which quartile is the widest? Yeah, the second one. It varies the most. Okay, here's another box and whisker that has no left whisker. What's the minimum here? What's the minimum? Yeah, the minimum is a 3. Yeah, it is a 3. Q1, yeah, that's the edge of the box would be 3. The interquartile range is obvious, it's 1. Now the median is not as obvious. So I don't know if it's because my screen is kind of blurry, I don't know if it looks better on your page or not, but it looks to me like if anything, this maybe looks a little bit thicker. So it looks like what they did was they put the median at the same place as where Q1 would go. And that would make sense also because that's the reason why there's no left whisker. The more bunched up there. So I would, I could be wrong on this, it could, but my interpretation of this is that the median also happens to be at like there's so many threes, three, 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 that the three is not only the minimum, it's not only Q1, but it's also the median. Just a bunch of threes. Which quartile here would then have the most variation? Which quartile is the most spread out? The first quartile goes from the min to quartile to Q1. The second one goes from Q1 to Q2. The third one goes from Q2 to Q3. The last one goes from Q3 to Q4. Which is the one that's the most spread out here? No, the third one goes from the median. That's only from the median to, it's only 1 unit apart. Yeah, the fourth. The last quarter. Determine the suggested statistical measures again. All right, so here for the first time we have an outlier. Just for fun, what's our outlier here? So that we know how to read a box and whisker plot. What's my outlier? 9. Yeah, 9 looks like an outlier. So my minimum here is 0. My maximum includes the outlier, which is 9. Okay, you have to include an outlier as a maximum. The only outlier is 9. And where's my median? 5. 2. The median's the one in the middle of the box. 2. Whoever just said 5, what is 5 here? It's Q3, yeah, it's the upper quartile. 5 is the upper quartile. No questions? I'm moving on. Last page. Finally made it. Given this data set, determine which, if any, of the data points are outliers, and then create an advanced box and whisker plot. I don't know what the difference between advanced and not is, but let's just do a box and whisker. In order to figure out outliers, they have to be in order. Of course, they're not, so I'm gonna have to put them in order. Oh, I get it right. I mean, which one's gonna be an outlier there? I mean, I'm gonna still calculate it to see if there's any more, but which one can you tell? Definitely is gonna be an outlier. The 5, yeah, the 5 is so far away from the rest of them, that's gonna have to be an outlier. 62, 64, 75, 75, 80, 90, 94. How many elements are there? How many elements? 10? Did I count it wrong? I'm counting 9. Yeah, so that's an odd number, so there is a median that's clearly in the middle. That's going to be 75. I can go ahead and put my line there at 75. When you have an odd amount, and you're going to calculate your quartiles, you do not include the median. You forget that it's even there. How many are on each side of the median? 4, but since 4 is an even number, now you have to average the 2 in the middle. So in between 62 and 64 is 63. I got to kind of guesstimate where that would be. In between the average of 90 and 94 is 92. If I add 90 plus 94 and divide by 2, I get 92. So that, that. The other boxes don't have that little point in the middle, so you don't have to. But you look at the one drawing. So now, let's see, we know that the -5, I have to put a point there. I just don't know if my whisker is going to go, well, I can already tell, I know my whisker is not going to get there, but, and then 100. But now when I do the interquartile range, that's going to be, we said 92, interquartile range, Kiara, is 92 minus the first quartile, which was 63. And that gives me 29. But I got to get that 29 and multiply it times 1.5. Ushka, 43.5. Did I do that right in my head? 43.5, 29 times 1.5. So then I have to get that 43.5 and do the low end, which was 63 minus 43.5. So that gives me 19.5. And then I got to do the high end, which was 92 plus 43.5. Is 135.5. So do any of these numbers fall outside of 19? Are there any numbers that are not in between 19.5 and 135.5? Are there any numbers that do not fall inside of those two? Yes, we said it from the beginning. It was pretty obvious which one it was going to be. It's just one of them. The 5 doesn't fall inside. So guess what? So I'm going to leave the 5 there. It's not like I don't plot it. But now, since I need to take a whisker somewhere, I'm going to go ahead and put the 62, which, wow, that's going to be really close. It's going to be a really small whisker. I'm going to put the 62 somewhere there. The whisker is only going to go to the 62. The other whisker can go to the 100. And then the poor little 5 is just out there by itself. Nobody to play with. Where did I get 62 from? Where did I get the 62 from? Yeah, that was the second lowest. The 5 is the minimum, but the next lowest was 62. That's why that's the one that gets the whisker. They need a whisker. Ree, no? Confusion? What are you confused about, Ree? When I get mine, okay, let's go. Do you know how I got to 29? You know how I got 43.5? So once I get 43.5, I'm going to get that and subtract it minus Q1. That's what gives me 19.5. And I'm going to add it to Q3. That's what gives me this. So then think of this as like a range. It's like a low end and a high end. It's like a span. Do any of those numbers not fall inside of those two numbers? 5. 5 does not fall inside. 5 is outside. 5 is less than 19.5. So you still plotted it. It's still considered your min, but it's also considered to be what's called an outlier, and that's spelled wrong. I-E-R. When you have an outlier, that just means when you draw it, you don't take the whisker all the way out to it. You would then take the whisker to just the next biggest, which is 62. Okay, Marquise? Cool. No questions and no more questions. Kiara, yes, good. All right. Test data for class 1. So let's, everything, box and whisker and range, everything. Ooh, it works. I'm just gonna put these in order for you. Hassle. How many will we have? 1, 2, 3, 4, 5. We have 11 of them. So let's go in order. That 36 looks out of place, but see, 36. Then 56. 67, 77, 82, 83, 87, 89, 91, 95, 100. So since there's 11 numbers, 1, 2, 3, 4, 5, 6, yeah, 11 numbers, the one in the middle is going to be the sixth number. That's the median. 1, 2, 3, 4, 5, 6. So the median is 83. My Q1, when you have an odd amount of numbers, you have to take that out. But I still have 5 on each side, and 5 is still an odd number. So my Q1 is 67, and my Q3 is 91. So 67, 91. My interquartile range will be 91 minus 67, which is 24. My overall range will be 100 minus 36, which is 64. Now let's box it up. The median is 83. That's like right around there. Q1 is 67. That's like right there, and 91 right there. Boxy, boxy. Then the minimum is 36, but that's sure looking like an outlier. We'll test it to be sure, but that's going to be 36. And then on the high end, we have 100. You can also do this visually. Like I would hesitate to advise you to do it because I think you could screw it up. But like on something like this where you have a grid, right? Like we're just trying to see if something falls. Look, watch. What does this distance here represent? That distance, what does that represent? The distance from here to here, what does that represent? Somebody that understands what we're doing. What does it represent, the distance from quartile 1 to quartile 3? What does it represent? Your interquartile range. So that 1.5 that you were just asking about, Kiara, like all we're asking is if you get that distance and add another half of it, that distance appears to be how many boxes roughly? It's like 5 boxes wide. It's about 5 boxes wide. So what's half of 5? 2.5. So if you get the 5 and then another 2.5, 7.5 boxes, do any of these points out here fall 7.5 boxes outside? Yeah, it doesn't look like it's going to, but let's confirm it mathematically. So maybe the 36 won't be an outlier. My interquartile range here is going to be what we said is 24. We like even numbers because 24 times 1.5 is 36. So I'm going to get 65, which is the low end, minus 36, that gives me 29. On the high end, 91 plus 36 is 127. So read, do any of the numbers fall outside of 29 and 127? Are there any number that's less than 129 or greater than 127? No. So actually this doesn't have any outliers. I can take the whiskers all the way to the max and the min. There. Here's another test data for a class, and let's do the same thing for class 2. Oh, and at the end they're going to make us compare everything? Fun. This has 1, 2, 3, 4, 5, 6, 7, 8, 9. This also has 11 scores. Okay? So 55, 65, 68, 75, 79, 81, 84, 90, 92, 95, and 100. So since this also has 11, the sixth one is the one in the middle. That's going to be 81. And then 68 and 92 are the quartiles. So 68, 81, 92. Interquartile range is 92 minus 68, which is 24. Total range is 100 minus 55, which is 45. Uh, 81, just right here, very close to the 80. And 68 is going to be like right in the middle of 65 and 70, a little bit closer to 70. 92 will be outside of 90. Box. The minimum is 55. The max is 100. And I mean, you can already tell by looking at the pictures. Does it look like any of that max or that min falls outside? Like if I were to get this distance, and then on top of that, add another half of that distance, does it seem like any of those points are going to fall outside? No, it doesn't. But I know that you guys love this, so I'm going to confirm it anyway. Mathematically. Are you planning on fighting crime after school? This looks like a job for Hoodie Man. Interquartile range again was 24. I got 24 last time too. 24 times 1.5 is 36. You 68 minus 36 is 32, and then 92 plus 36 is 128. Obviously, nothing falls outside of that. So now let's compare these last two problems. Which class has the higher? Let's go with Kiara. Kiara, which class has the higher median? Class 1 is the number 6. Class 2 is from number 7. Which has the higher median? Class 1, class 2. Class 1, yeah. Which class has the lower first quartile? So which one has a lower Q1? Also class 1. Which has the highest test grade? So which one has the highest max? Did they both have 100? Which class has the highest test grade? So they both do. What was this grade? It was 100. Which class has the lowest test grade? The first one, right? The first one had that like 36, was it? 36. So class 1 again wins 36. And then we have a brand new question, which is our last one. They give us here two box and whisker plots. In which year was the corn yield more varied? So yeah, I guess if they just say overall more varied, they're just talking about your range. Which one has the greater range? 99. Yeah, it's more spread out. How does the median yield in 99 compare to the median yield in 97? Yeah, it's greater. Say higher is fine, but say greater. Not really bad. Marquise, man, you're starting to worry me, dude. You want to be Nakai's sidekick? Does anybody want to do that? I know we skipped a couple. I feel like we skipped 10 minutes left. And we did the backpack one. This one, like the company selling boxes of crackers. You want to do that one? Does anybody want to do that one? Median mode. You've really been a great audience today. I mean, the amount of dialogue has been overwhelming. We don't have to do it. I mean, that's the question. I'm not like, it's up to you. If did anybody try it and got stuck on it or anything? You got stuck on it, or you didn't try it? All right, so we'll leave it at that. You can just hang out for the last 10 minutes. Just remember, you got a quiz tomorrow. Remember also that this week the homework is completely at home, and next week it may or may not, depends on how fast we finish. But this week there's no computers.